Okay. Hi guys, we have started streaming, so let's begin. My throat is a bit garbad. I believe I'm live now. Yes, I am live now. Just give me a moment. I'll quickly share this class on Telegram group which I have shared. Just give me a moment. Okay, so let's get started. As you guys already know, that we are going to start with the D and F block chapter, and this is your Unacademy, ISC and ICSE boards, and we are going to rock together, right? We are going to ace in your term 2 examinations for sure. Okay, and yes, here is my pen. So you know already, if you want to get plus subscription, then you can get flat 10% off if you use my code, that is KIRTIS live, that is Kirti S live. So like if you use this code, you will get an additional like flat 10% off you will get. Okay, that's the deal guys. So it's amazing, and apart from this, very like more offers are also going on, correct? And okay, yeah, a lot of offers are going on. Let me just quickly set, sorry. Okay. So we know this already. Let's move on to the next page. Yeah, so here it is. I'm in front of you, your chemistry educator guys. My name is Kirti Sharma, and I have completed my graduation from University of Delhi, and it's been like 5 or 6 years since I've been teaching cute and smart students like you, like I say always. And I believe now it's your turn. Okay, so I believe that everything is going on amazing, and you guys are also having fun. Just let me know if you have any doubt, and if you don't understand anything, you have any doubt, then you can just reach out to me on on Telegram or Unacademy Messenger. My username is Kirti underscore Sharma. It is Kirti underscore Sharma 1223. This is my username for Unacademy Messenger as well as for Telegram. So you can reach out to me by this username. And before starting, what will we study today? So you guys already know that we were discussing D and F block. What were we discussing? We were discussing D and F block elements. Okay, we discussed we had a short introduction in the previous in the previous lecture, right? Here you can see that this is my code, which is Kirti S live, and of course you can use it if you want to get an additional 10% off, or you can also use this code if you want to attend the free live class, that is your special class, right? So you can use that as well. Okay, let's move ahead now. Before starting, you can follow Unacademy Champions on Telegram. The link is given to you in the description box. Okay, and subscribe us on YouTube now. Sorry, my throat is like, it's freezing here, quite cold here, so my throat is like a big gutbird. Okay, So we are targeting 1,000 subscribers in the beginning. So like, you are the guys, propagate it, promote it within your friends and family, because a lot of students like who particularly belong from ISC boards, they don't know that this category has been launched. Okay, so like that's the biggest thing. So only you guys can help us to, in order to such that everyone knows, everyone is aware that yes, this category is there now. So it's your it's your duty to do that, right? Here, as I told you, that I have an offer for you, and that is, if you get plus subscription for at least 12 months, for a minimum of 12 months, or you can say if you get the subscription for 12 months or above, then you will get extra 3 months K-12 subscription. Okay, that is, if you get the subscription for 12 months, you will, like, we will provide you the subscription for 15 months. For how many months? It will be for 15 months. So it is a quite good deal for you. Apart from this, you already know that the batches have already been launched on Plus platform. As you can see here, that this batch was launched on 17th of January. Okay, the mode of delivery is going to be in English, and again there is one more offer, and you can club these two. That is, like, the previous one was like, if you get the subscription for 12 months, you will get 3 months free, correct? And the second one is, whether you are in class 11 or you are in class 12, get the subscription for class 11, so that you will get the class 12 subscription for free. Okay, so this is another thing. This is a like, this can be one of the biggest benefit for you. Apart from it, like, if you get the subscription for class 9, I'm telling you the whole offer. If you get the subscription for class 9, you will get class 10, 11 and 12 subscription for free. Okay, if you get the subscription for class 10, you will get class 11 and 12. I'm talking about ISC. Okay, you will get class 11 and 12 subscription for free. If you subscribe for class 11, you will get class 12 subscription for free. So this is the deal. So you can club these two offers. Number one is this one, and number two, get the subscription for a minimum of 12 months, so that you will get additional 3 months. Okay, and apart from it, you can always use my code all over Unacademy, that is Kirti S Live. My code is Kirti S Live, and if you use this code, you will get an additional 10% off. So this is a good deal for you. You can see here, this is Maverick's batch for class 11, and that's it. Okay, now let's move on to the next let's move on to the D and F block now. Okay, what we have discussed till now is like regarding the D block elements. So we know what happens in case of D block elements. The electrons which are present in the last electron which is present, it enters in the d orbital, or you can say in the d subshell. Okay, and d block kahan se kahan tak hota hai? It is from group 3 to 12. We know, like, if something like this is the shape of our periodic table, right? Something like this, I would say, is the shape of our periodic table. But yeah, something like this is the shape of the periodic table. So this is like, here also we have some elements. So these are S block elements. Here in the middle, these are D block elements. Here are the P block elements, and here are these are at the bottom of the table. These are the F block elements. Okay, we discussed already. So the D block elements of the periodic table belonging to group 3 to 12 are known as D block elements, right? Because because in these elements, what happens? The last electron enters in the D subshell or in the D orbital. Okay, so that's why. Now, the D block elements lie in between S and P block elements in the long form of the periodic table. And what is the general electronic configuration? We discussed that it is n minus 1d, 1 to 10, ns 1 to 2, ns 0 to 2. 0 इलेक्ट्रॉन्स भी हो सकते हैं इस ऑर्बिटल में, 2 तक हो सकते हैं, या तो 0 या तो 1 या तो 2. So this is the general electronic configuration, n minus 1d, 1 to 10, and ns 0 to 2. This is the general electronic configuration. Okay, I believe that there is no doubt till now. You can feel like my voice is breaking. Sorry, my throat is a big gadbad in winters, so I'm sorry for the inconvenience, but everything's cool. Yeah, so this is our S block as we discussed. This is the D block, this is P block, and at the bottom it is our F block. In the beginning, we will discuss about D block elements, although we will cover the 100% syllabus only on Plus platform. Okay, so yeah, you can see here that in case of D block elements, we have 4 D series. We have how many D series? We have 4 D series. Okay, we have 4D series. This is 3D series, this is 4D series, this is 5D series, and this is 6D series. I told you to learn at least like 3D series, right? I already told you scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, so remember this 3D series. Okay, and I told you already, if you want to jump from 3D series to 4D series, then what you need to do? You need to add how much? You need to add 18, right? If you want to jump from 3D to 4D series, add 18. If you want to jump from 4D series to 5D series, add 32. How much? 32. We won't be dealing with 6D series because this is radioactive in nature. So this is like, you can say, basically not in our syllabus. That is why we won't be dealing with 6D series. The main series which we will be dealing with is going to be 3D and 4D series. Okay, that will be our 3D and 4D series, correct? I believe that there is no doubt till now. Okay, I see like something is burning. Just I'll be back in a moment, guys. Feeling like something is burning. Just wait for a while. Let me go. Yes, guys, I'm back. Sorry for the inconvenience. I thought something was burning, and it turned out to be something else. So okay. So yes, I told you this already. Like, if you want to jump from zinc to cadmium to mercury, you will just, if you want to jump from 3D series to 4D series, you will have to add 18. If you want to jump from 4D series to 5D series, you need to add 32. Okay, so like, just for your clarification, you can do this. Okay, and you can see here clearly. You can check as well. If you see that here, iron has an atomic number of 26. If you want to predict the element which is just below the Fe, so what will be its atomic number? It will be 26 plus 18, that is 44. You can check here. Okay, if you want to check what will be just below the Ru, it will be osmium, Os. Okay, so you need to add 32. So you will do 44 plus 32, that is 76. So you can do it, and I have already told you to remember the 3D series. Okay, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, remember this. This is going to be very useful for you. All right, guys. So you need to learn this series. Then we understood what are transition elements. So I told you, like, D block elements we understood, and what are transition elements are when the d orbital, when the d orbital has you would say it is partially filled. What is it? It is incompletely filled. So that is why when your d orbital is fully filled, in case of zinc, in case of cadmium, in case of mercury, in that case you don't call it as transition element. Yes, they are d block elements for sure, but zinc, cadmium and mercury, they are not transition element. Rishank Mudgal. Okay, hi bache, how are you? Is that clear? Now let's move on to the next. As I, like, you can see here, these are the 3D series from scandium to zinc, right? And here you can see all the electronic arrangement, electronic configuration which is written here. Okay, I specifically told you to remember the general electronic configuration of chromium and copper. Although I know you know how to write configuration, right? 1s2, 2s2, 2p6, you remember. I know this. But in case of chromium and copper, what happens is, like, see, we know in case of d block element, what is the general electronic configuration? It comes out to be n minus 1d, 1 to 10, ns 0 to 2. Correct? So in case of chromium, okay, let me tell you one thing before. I have already discussed this, that fully filled and half filled orbitals are exceptionally stable. Whenever an orbital is either fully filled कि सारे में ही electrons है, or either it is half filled, exactly half filled, like you can see here. In case of chromium, you can see it is half filled. See, if you fill generally, see the electronic configuration of chromium, like the atomic number of chromium is 24. If you try to write the general electronic configuration for chromium, what will it be? You will say, ma'am, argon tak ye to 18 tak to ho gaya, done hai. You will say, ma'am, it will be 4s2 and 3d4. You will say that it will be 4s2, 3d4. But instead, what happens? One electron from the s orbital jumps into the d orbital, so that it becomes 4s1, 3d5. What it becomes? It becomes 4s1, 3d5. Clear hai? So that is why in case of chromium and copper, there are half filled and fully filled d orbitals. So this is the case. All right, this is the case. So you definitely need to remember the general electronic configuration for chromium and copper. I believe that it is clear till now. All right, let's move ahead. So here you can see how are D block elements and transition elements different from each other. Although we have already discussed this, that what happens, all D block elements are not transition elements, but all transition elements are in the category of D block, correct? Because we know that in case of transition elements, we say that elements who have incompletely filled d orbitals, only those are considered as transition elements. So whenever d block elements like the d orbital is fully filled, as in case of zinc, cadmium and mercury, so these are not considered as transition element. Please remember that zinc, cadmium and mercury, these are not they are not in the category of transition elements. Okay, you can see here that all D block elements are not transition elements, because D block elements like zinc have full D10 configuration in their ground state as well as in their common oxidation state, which is not according to the definition of transition elements. All right, I believe it is clear till now. Let me know in the live chat beta if you have any doubt. Okay, if you have any doubt, then simply let me know in the live chat. Okay, let's move ahead. So we were discussing the properties. Okay, we were discussing the properties of the D block elements, right? So the very first is atomic and ionic size. What is the first one? It is atomic and ionic size. So let's discuss this. Okay, although we have first melting point and boiling point. Okay, what can we do? We can discuss for the atomic and ionic radii. Okay, let's move on here. Okay, where is my eraser? Okay, all right. If we talk about atomic or ionic size, okay, if like first let's talk about in the series. Okay, from left to right, the 3D series, if we talk about, we know that it is scandium, titanium, vanadium, chromium, manganese, cobalt, nickel, copper, zinc, right? Copper, zinc. This is the series, right? So what happens? From scandium to manganese, we can say that from scandium to manganese, जो साइज होता है वो डिक्रीज होता है. Size decreases. Now you'll be like, okay, obviously yahi to hoga, because what happens, like when we move from left to right, so we know that the electronic charge, the nuclear charge increases, right? Okay, chalo, let me get to you in this way. Let me make you understand all this stuff. Okay, it is like this, right? Electrons here and electrons like here as well, in this manner. So we know that inner shell के electrons outer shell के electrons को repel करेंगे, right? The electrons of the inner shell are going to repel the electrons of the outermost shell. Why? Because same charge hai, both are like negative charges, and we know that the negative charges repel each other. So we know that they will repel each other. सही है? So this is your electron repulsion. This is the first force which is working, okay, anywhere. And the second force is, if I tell you, like this is our nucleus, right? This is our nucleus in the center. Now nucleus will be attracting the electrons of the outermost shell as well, because positive charge, negative charge, they will attract each other. So here two forces are working, correct? One is electron repulsion, and the another one is nucleus और electron के बीच में जो attraction है. There are two kinds of forces which are working, and both of them are like opposing each other, है ना? If these electrons are repelling each other, so electrons are repelling, and as a consequence the size of this atom will increase, correct? If your nucleus, if the attraction between nucleus and electron is more, then what will happen? Tell me. The size will decrease. Why? Because nucleus is trying to attract the electrons, right? This is what happens. So from scandium to manganese, I will say that this nucleus electron attraction is greater. It is greater than electron repulsion. It is greater than, क्या हो गया, repulsion. Okay, repulsion. So जिसके वजह से क्या होगा, the size will decrease. As a consequence, you can say that the size will decrease, right? Now from manganese, what can we say? That from manganese up to आगे यहाँ से till copper, here we say that your nucleus और electron के बीच में जो attraction है is almost equal to the electron repulsion. So in this case, what will happen? Size is almost same. मतलब कि even if it is decreasing, it is like a half picometer or 1 picometer, that's it. So you can say that size is almost same. Okay, and if we go further, we can say that the electron repulsion is greater than, see, because we know that as we move forward, electrons बढ़ रहे हैं, zinc में it is like fully D10 configuration है. So there are so many electrons that they are repelling each other very much. That is why your electron repulsion becomes very stronger than the nucleus electron attraction. So what will happen in the third case? The size will increase. Is it clear, guys? I believe that there is no doubt till now. Let me know if there is any doubt. Okay, let me know, guys, if in this concept, if you have any doubt, then simply let me know. All right, from scandium to manganese क्या हो रहा है? We know that the nucleus electron attraction is greater, that is why the size is decreasing. Then it is almost same, because your nucleus electron attraction and electron repulsion is almost equal, so that is why size is almost same. And in the end, because we know that in case of zinc, the it has full D10 configuration, and as a result, what will happen? The size will increase because the electrons will repel each other from a very strong force. Okay, and one more thing which I would like to let you know is that when these electrons are repelling each other, these electrons are repelling each other, right? The electrons of the innermost shell are trying to repel the electrons of the outermost shell. So this is called as shielding effect. What do you call this? You call it as shielding effect. Sometimes it is also called as screening effect. You can say that this is your screening or shielding effect. Okay. And if we talk about the order of screening effect or shielding effect, so S का screening effect बहुत ज़्यादा होता है, then P, then D, and in the end it's F. Okay, that is the order for screening effect. S orbital का सबसे ज़्यादा होता है, then P, then D, and in the end it's F. Okay, so that is the order for your for your screening effect or shielding effect. All right, is it clear, guys? Now if we talk about melting point and boiling point, so you like generally though we know it is very high, because again in case of D block elements it has like I would say large number of unpaired electrons, so like the bonding will be metallic bonding, and that's why you will say that the melting point and the boiling points are going to be quite high. See, if you look at the trend in terms of series, so see, you will see that first it increases and then it starts decreasing. The melting point and boiling point, first it increases and then it decreases. Now why this happens? So, and one more thing, you will see that there is a dip in case of magnesium, right, manganese, and then ma'am, where can I get these PDFs? Beta, if you want the PDFs, then you can join the Telegram group. You can find me on Telegram by my username, that is Kirti_Sharma 1223. I will share the PDFs with you, and the better option which I have for you is come to the free live classes. I'm inviting you in the free live classes, as the name suggests that it is free. So like you just need to download Unacademy app and select the goal, either ISC 11 or ISC 12. There you will find me, Kirti Sharma. Okay, and in the free live classes you will have a different experience. Okay, there we have polls, we have raise a hand feature. Like the class is very interacting, okay, because it is like more for focused students, and after the class you will also get the PDF on the app only. Okay, so you can do that. It will be quite interesting then, so you can do that. Okay. So yeah, as I told you that the melting points and the boiling points, they first increases and then decreases. You will see that there is a dip in case of manganese and then TC, right? Why? Because you will see that they are half filled. They both are half filled, so they are very stable, and that's why they are not very impatient to make the bond, because they are already very stable. So that is why, like, you can say that their bonding character is a bit less than the others. So that is why you see a dip in case of manganese and Tc. Okay, so as you can see here, a large number of unpaired electrons take part in bonding, so they have very strong metallic bond and hence high melting and boiling point. Okay guys, I hope that this is clear. And one more thing in case of size which we should cover is that when it comes to size, we discussed when we go from left to right. Okay, let's discuss when we move, say, from 3D series to 4D series. Matlab you're going from top to bottom. Okay, when you're going from 3D to 4D series, tab kya hoga? What will happen in that case when you jump from 3D to 4D series? So you are like, okay, ma'am, quite obvious, when you move down the group, what happens? Shells are added, right? You will say that, ma'am, we add shells. Okay, shells add होते हैं, and quite obvious, if this is something, इसमें अगर आप एक और shell add कर दो तो क्या होगा? Size will increase. So of course यही होता है, 3D से 4D पे जाने पे size increase करता है, size increases. Reason आपको पता है, because of addition of shells, because of addition of new shells. ठीक है, but जब आप 4D सीरीज से 5D सीरीज पे जाते हो, when you jump from 4D series to 5D series, what happens in that case? Size remains almost same. Now you'll be like, ma'am, abhi bhi to like you will add shells na, to ab ki baar why size is almost same? Size is almost same. Then you'll be like, ma'am, why this, matlab why is it happening? So it is because of lanthanoid contraction. It is because of, let me it is because of lanthanoid contraction. अब आप बोलोगे, मैम, what is lanthanoid contraction? So I will tell you what is lanthanoid contraction. See, as I told you, like when you jump from 4D to 5D, तो 5D से पहले, before filling the D orbital, you fill the F orbital, right? 4F को fill करते हैं, you fill 4F orbitals. And we know that the screening effect, or you can say the shielding effect of F orbitals are very poor. So what will happen when shielding effect is poor? That is, the electron repulsion is very less. So because this repulsion is very less, so in this case what will happen? The nucleus will attract the electrons with a stronger force, and hence जो size increase होना था actually, वो size में increase नहीं आ पाएगा. ठीक है, that is the deal with that's the deal with lanthanoid contraction. Is it clear? It is the deal with lanthanoid contraction. I hope that it is clear. Alright guys, let me know in the live chat if you have any doubt. We will get it sorted. Clear hai? ठीक है? So we discussed the atomic and ionic size when you go from left to right. So it first decreases, then it is constant, and then it in the end it increases. Okay, and when we move from 3D series to 4D series, then the size increases because of addition of new shells. And when you jump from 4D series to 5D series, the size remains almost the same because of lanthanoid contraction. What is lanthanoid contraction? That is like when you jump from 4D to 5D. Before filling the electrons in the 5D series, you fill them in 4F. And we know that the screening effect, or you can say the shielding effect of the f orbital is very poor. That is, the electron repulsion is very less. If the electronic repulsion is very less, then the nucleus tends to attract the electrons with a greater force. As a result, the size almost remains the same when you jump from 4D series to 5D series. Is it clear, guys? I hope it's clear. All right. Sorry. I hope this is clear and you have no doubts in this. Okay. And you can see here are some of the offers which are going on, that if you get the subscription for class 11, if you get the subscription for ISC class 11, you will get the subscription for ISC class 12 for free. And second deal which is going on is, if you get the subscription for 12 months, you will get an additional 3 months subscription for free. Okay. And in the end, you guys already know, if you use my code, that is Kirti S Live, you will get an additional 10% off. So using these, the plan is going to be quite beneficial for you. So go and grab the offer right now. Okay, guys. It will be very, very useful for you. Cool. Let's move ahead now. We have discussed melting point and boiling point. You can see here atomic radii of fourth period. You can see that these are some of the features of the app. That is polls and raise a hand feature. In polls, I give you a question. And 4 options, and those 4 options will appear on your screen, and you need to vote like which option is correct, option number A, B, C or D. Okay, so when you do that, I will have all the data, like how many % of students have answered correctly, how many of you have answered incorrectly. So I have the whole data, and according to that, a leaderboard is created, like who answered first and who answered more the questions correct. So on the basis of time, and on the basis of the correct answer, of course, the leaderboard is created. And raise a hand feature is there. That is, like, just in an offline class, what happens, like whenever you want to say something, you want to talk, you want to ask something, so you just raise your hand. So this feature is available, and using this feature, we can literally talk during the class, and everybody can hear our conversation. So this feature is pretty interesting. The class becomes very interacting using this feature. So it's pretty nice. Self-study and free live classes. We have courses, we have batches for you. I have already told you that Mavericks batch is like launched yesterday, and you can take part in it, and we will cover 100% syllabus of the term 2. So you guys can get the subscription. Here we have test series for you. You can see. So here is again the same description which we started. That is, along the rows, what happens? Nuclear charge increases, but penultimate D subshell has poor shielding effect, so atomic and ionic size almost remains same, right? The radii of the third series are virtually the same as those of corresponding members of the second series. This phenomenon is associated, this is the description of your lanthanoid contraction. We just discussed it, okay? That is, like whenever somebody asks you regarding the lanthanoid contraction, then simply before filling the 5D series, before filling the electrons in the D subshell 5D wala, you need to fill the electrons in the 4f orbital. And we know that the screening effect, or you can say the shielding effect of the f orbital is very poor. That is why the effective nuclear charge increases, and as a result the size, like almost it remains the same. Okay, this is the reason. So you can see here the phenomenon is associated with the intervention of the 4f orbital. The filling of 4f before 5d orbital results in a regular decrease of atomic radii called lanthanoid contraction, which essentially compensates for the expected increase in the atomic size with increase in atomic number. Okay, so you can see here the net result of the lanthanoid contraction is that the second and third D series exhibit similar radii. Okay, we have already done this. Cool guys, I believe that there is no doubt till now. Okay, you can see here the trend of ionization energy of fourth period transition elements. And yeah, you can see here that when we go from left to right, the nuclear charge increases, right, which accompanies the filling of the inner d orbitals. There is an increase of ionization enthalpy along each series of the transition element from left to right. Okay, you can see here that transition elements have variable oxidation states because very small energy difference is there between n-1d and ns subshell electrons, right? So that is why you can see here, and like whenever like you see in the middle, whenever you look at the middle of the d block elements, that's the element which exhibits the most oxidation states. You can see here manganese can show the oxidation state from +2 to +7. Scandium only shows +3. Titanium only shows a 3, +2, +3, +4. So you can see now how it is increasing the oxidation state, right, as you go in your 3D series, right? So the one in the middle always shows the most variable states, most variable oxidation states. All right, you can see here the elements which give the greatest number of oxidation states occur in or near in the middle of the series. I told you already, manganese for example exhibits all the oxidation states from +2 to +7, right? Low oxidation states are found when a complex compound has ligands capable of pi acceptor. See, we are also doing the chapter complex compounds, or you can say coordination compounds, in special sessions and in plus sessions. So I would suggest you see, because we are only going to cover the 100% syllabus in plus sessions, so it's better you take the plus subscription as soon as possible. I have told you the deals which are going on, and again you can use my code, that is Kirti S Live, and you will get an additional 10% off. Okay, and here you can see that for example NiCO4, FeCO5, the oxidation state of nickel and iron is 0, right? And also colored ions, we know that transition metals, we know that the transition metals form coordination compounds, right? Again, I have already told you regarding the coordination compounds, we are doing it on special platform and on plus platform. Okay, so you can come and join that class. So most of the transition metal compounds, ionic as well as covalent, they are colored solids, matlab they show variety of colors. Okay, so generally the elements or ions, ऐसा देखा जाता है कि the elements who have like a large number of unpaired electrons, they produce colored compounds. Okay, so again, if someone tells you to give the reason why transition elements, or I would say why the D block elements show why they have colored ions, why their compounds are colored, so what is the reason? That is, they have large number of unpaired electrons which are responsible for the colored compounds. Okay, that's what you say. You can see here, they are found in a rainbow of colors: scandium oxide, titanium oxide, sodium chromate, yellow in color, right? Manganese chloride, tetrahydrate, okay, cool. Potassium ferricyanide is quite reddish orange in color. So you can see that these exist in a variety of colors. Alright guys, so you can see here, and also the D block elements are very good catalysts. The D block elements are very good catalysts. Very good catalysts. Okay, you can see here that we know already that iron is used in the production of ammonia, that is your Haber's process, है ना? Cobalt is used in the synthesis of gasoline. Vanadium oxide, that is V2O5, it is used in contact process. So you can see here, again, this property of like being a very good surface, like the D block elements provide as a catalyst, right? It is also because of large number of unpaired electrons, because in their D orbital there are large number of unpaired electrons, and that is also the reason that it shows variable oxidation states as well. So in most of the cases they provide large surface area. Pehla reason, there is large surface area which is available for, like, along with free valency as well. So these are the reasons you can see here, that this property is due to presence of unpaired electrons in their incomplete d orbitals, variable oxidation state of transition metals, and in most cases they provide large surface area with free valency. Okay, that is it for the day guys, and let me show you. Yeah, you can see here the features of Unacademy subscription features that we have for you, and here you can see that, and you know as well that now again there is an outbreak of COVID, so it's better to just stay at home and learn live with the comfort of your home, right? With the top educators of India, I would say. And once you get enrolled, you will have like unlimited access to all the courses which are like available in your category, and there are regular doubt solving sessions, because like it's mandatory. Every fourth session in plus is a doubt solving session. There are answer writing sessions, because sometimes what happens, you uh, like sometimes students grab the concept but they don't know how to write the answer in a correct manner, especially in like when you have to write the answers when you have a subjective exam. So in that case it becomes a problem. All right, so we have answer writing sessions for you, and as I always tell you that we cover the whole syllabus only at the plus platform. So it's better to take the subscription and let's study together. Since we are here, so our mentorship and guidance is there for you. Study material is provided to you in the PDF format. Practice tests, live tests, and daily practice sessions and batch courses. Everything is there, so you will have fun. Okay, and as I always tell you, to get the subscription for a longer period of time, so that it will already cost you lesser. And these days, you know very well, the offer is going on. That is, if you get the subscription for class 11, you will get the subscription for class 12 free. We are talking about ISC boards. And if you get the subscription for 12 months, you will get 3 months free. You will get 3 months subscription free. And if you use my code, that is Kirti S Live here, you will get flat 10% discount. Okay, so you can combine all these three offers and you can get. Hi Pragya, you are late. Captain's music. Okay. All right. And you can take the maximum benefit, Pragya and Pragati, right? So like I told you, there is a deal for you guys, especially if you get the subscription for class 9, class 10, 11 and 12 subscription is free. If you get the subscription for class 11, class 11 and 12 subscription for free. If you get the subscription for class 11, class 12 subscription is free. And use this code, that is Kirti S Live, and you will get 10% off. And if you get the subscription for 12 months, you will get 3 months free. So it will be very beneficial, guys. Go and grab this offer. That is it for the day. You know already that Param batch, Champions batch, these are the existing batches, right? And you already know how to watch the special sessions. So that is it for the day. Okay, best of luck. Okay, this was like a student in the previous batch who was like, ma'am, wish me luck on the screen. I was like, okay. So yeah, Unacademy, let's crack it. That is it for the day. If you want to be like, if you want to reach out to me, you can do that on Unacademy Messenger or Telegram. My username is Kirti_Sharma 1223. So you can use this code, and you can reach out to me by this username, and the code is Kirti S Live. The code is Kirti S Live. Cool. That is it for the day. See you in the next session.